So our last conic section we're going to take a look at is one we've definitely seen plenty throughout the semester. It is the parabola. And so this first half of this page here kind of recaps the stuff we know. We understand there's the two different forms, kind of a graphing form and a more standard form. We know graphs can open upward and downward with this idea of the vertex being at h comma k, or if you consider the general form of ax squared plus bx plus c, you can find the vertex from our vertex formula of negative b over 2a. So this is the parabola that is a function. It's a critical part to algebra, as we've done a lot with it. However, the general definition of a parabola is that this shape can go in either direction, meaning not only up and down, but left and right. So opening what we could call vertically or horizontally. And so to get into that definition a bit more takes it a little further than what we've done up prior to this section. And so the idea, we still have this thing we call the vertex. That is still the same name for that point there. But with this idea that it can open left and right instead, we focus on, well, the focus and the directrix of a parabola. So with a parabola shape, you have your vertex, and the definition, kind of going back to what we saw with the ellipse and the hyperbola, is the points on this graph here are points that are equidistant from the vertex and the directrix. Now it's we call perpendicular distance. So if you were to draw a line from this point to any point on this graph, right, any distance, but then look at the vertical, or the perpendicular distance to this line here called the directrix, they'd be the same. So the distance from this point or from the directrix to any point on this parabola is the same. So notice we have a single focus. We do not have foci like we had for ellipses and hyperbolas. And instead we have this directrix. Now we do this other axis that we've talked about before, the axis of symmetry. That's the idea of the line that kind of splits your parabola in half, where it looks the same to one side and to the other. Used to be the idea of to the left and to the right of the axis of symmetry, kind of going down the middle. Now, since we have this option for horizontal parabolas, we have the ability for it to be, running left and right to where our parabola looks the same above and below. So that's the two important features there, along with the focus and the vertex. So let's take a look at the formulas and how we can get this information from an equation. So the centered versions, the ones that are centered at the origin, or I should say the vertex at the origin, look like one of these two. Now, of the two, this is one, the second one, is the one that you're familiar with because it's got an x quantity being squared. Right, we've seen with x squared where we expected that parabola shape. Now, what we haven't seen is this form. Notice this form has x squared by itself, and over here with the y is an additional coefficient of 4 times some value of p. Okay, p is really the only defining characteristic here for this entire parabola, aside from when we move the vertex off of 0, 0. So p is important, but it's 4p times y that we would see on this right-hand side. Now, to get this horizontally opening parabola, left and right, it's the y quantity that will end up being squared, something we've not seen before. Again, something that we did mention a long time ago would lead to something that's not a function. Notice this does not pass a vertical line test. That's why we haven't really seen it up to this point. But with a y squared quantity on one side and just an x on the other, with the x now being the term that has this 4p coefficient on it. Now, the role that p plays is pretty simple. P is nothing more than the distance from your vertex to both your focus and your directrix. So when you have your vertex of either parabola, the distance along the axis of symmetry to go to get your focus or to find your directrix. Same thing here. P is the distance left and right for a horizontal parabola. P is the distance up and down for a vertical parabola. Okay? And then we add in the ability to shift that vertex by throwing an h and k in. And notice, just as before, h pairs with x, k pairs with y. Now, no matter which one you're looking at, whether it's the x quantity being squared or the y quantity being squared, right? That's the same. H is with x, k is with y. Same thing here, because hk will be the coordinates for our vertex. Since parabolas don't have a center, the hk is being used to find our vertex here. And then again, the values of p, you don't really need to memorize all these formulas. You just remember p takes you left and right for horizontal parabolas, and P takes you up and down for vertical parabolas. So let's take a look at a couple that are centered or vertex at 0, 0. Again, notice no pluses and minuses going on with these y's and x's here. So all we need to do is notice first and foremost the y being squared. So y being squared, that's one we're not used to, right? So we're used to x being squared being a standard up and down vertical parabola. So the y being squared tells us this is actually the new one. This is the horizontal parabola. Okay, so it's opening left and right. Now, the only other thing we need is, in this case, the number, the coefficient on x. That 12, remember this is supposed to be lining up to y squared equals 4px. So we'll just make this small equation, very simple equation, that 4p has to equal 12, divide both sides by 4, and we find this value of p equaling 3. And positive 3. That's one thing we want to know. Positive 3 is important. So if I bring back the other page, that's one important aspect to these, is these are all done, these pictures are drawn for positive values of p. If it's a negative value of p, it flips it. Think of a reflection, right? This is what we would get for a positive value of p, but if p was negative, then we need this parabola to be opening downward. Same thing for the horizontal. For a positive p, it opens to the right, the positive values of x, or positive direction. If you get a negative p, you want to flip it and have it open in the negative direction. That's one way to keep from having to memorize all the different situations of pluses and minuses and where things are, is just remember, positive is up or right, negative is down or left for our parabolas. So a positive 3 here tells me that from the vertex, which we know will be at 0, 0, and since this is a horizontal parabola, opening left and right, I can go 3 to the right, and since my parabola is supposed to open to the right, since it's positive, 1, 2, 3, that will be where my focus is, and it's because it opens around the focus. If I go 3 to the left, that is the location of our directrix. So that's our directrix, and that is our focus. From there, we can take our vertex or our parabola and again sketch the graph of it opening to the right in this case. And the question just simply says find the directrix, the focus and the directrix and graph. So we found that from the 0, 0 for the vertex, the focus is over here at 3, 0. And the directrix needs to be the equation of the line. Well, it's a vertical line located over here at x of negative 3. So it's the equation of the vertical line, x equals negative 3. And that's our graph. All right, next one. Now we see x squared, so we know this is what I'll call it our familiar parabola of a vertical parabola. And now we've got the negative 8 in front of our y, so we want 4p equal to negative 8, so p equals negative 2. So with a vertical parabola opening up or down, the negative is what tells us it's going to open downward. 2 is still the distance of p. So to start with our vertex at 0, to go up and down 2, since it's opening downward, going down 2 is where my focus will be. Going up 2 is where the directrix will be, and we know it opens around the focus. So with that, we have the focus located at that point of 0, negative 2, right there, and we have the directrix being the horizontal line located at 2, so y equaling 2.